Hey guys, so today we are going to learn how to put together a circuit using a breadboard, and then how we can code it using an Arduino board using a TinkerCAD Arduino simulator. So this will all be part of our Robot Art Show project, and this is kind of the meat of the project, so I'm really excited for you to get started going with that. So I'm going to start by sharing my screen with you, and here's what I've got so far. So as you can see, I have a couple tabs open. First, I've got my Arduino programming notes. Second, I have my Sparkfun Inventor's Kit experiment guide. So this is all of the instructions that I need. And then third, I'm going to open up TinkerCAD Circuits and click on that. And it should open up my TinkerCAD Circuits thing. And then I click Launch TinkerCAD Circuits. So when TinkerCAD Circuits launches, it'll start by giving me a really weird name up at the top. In this case, it's Daring Firen Cassie. You can change the name by clicking up there, and I'm going to call it Circuit 1B, potentiometer, since that is the circuit that I'm going to be working on. Okay, so the next thing for us to take a look at is to take a look at the instructions. So the Sparkfun Inventor's Kit, this is a set that we often use in the classroom with a hard copy, but now we're going to try to use it on a digital copy. So the Sparkfun Inventor's Kit experiment guide, you can start in the introduction, and I would suggest reading through the whole shebang. If you really want a hard copy version, you can download one right here. The version 4.0 printed guide, you can download it as a PDF, and you could print it off yourself, or you could have them print it and send it to you, and that costs $5. So you can find it on the Sparkfun website for a printed copy of the Inventor's Kit. You're looking for 4.0. Then you're going to scroll through these various pieces and read through each one. Base plate assembly is putting together the hard version, which we're not going to do because we're doing remote learning. The next part is the Sparkfun Red board, worth reading, but I'm going to skip through it. And actually, you're going to keep going, keep going, keep going. And I'm going to skip circuit 1A. I'm going to have you guys do it, but I'm going to show you how to do circuit 1B, which is a potentiometer. And the reason I'm going to do this one is because it incorporates an extra component of the serial monitor, and I want to show you how to access the serial monitor as well as how to change the coding and all that stuff. So in these instructions, the potentiometer, you can start by reading through what a potentiometer is and how it works. It goes through and gives you all of the components that you'll need to pull. So I'm going to end up pulling an LED, a potentiometer, a 330 ohm resistor, and some jumper wires, some connectors. Here's a potentiometer, and it explains kind of what it is and what it does. You should read through this part. And then it talks about the difference between analog and digital. Conveniently, we've already learned about that. You should still read through it and understand that we're going to take some analog information, A0 through A5, as an input. All right, I'm going to scroll through to the circuit diagram. I find the circuit diagram to be one of the most helpful pieces of information. And so now that I've got this circuit diagram set up, I'm going to take a look at it, and I'm going to try to set up my simulator in a really similar form. So I'm going to switch over to my simulator. I can see that I have an LED up here that my red board connects 5-volt and ground into the positive and the negative, that I've got a potentiometer coming off of that, and then there's a resistor connecting in to the positive side of the LED. So remembering that, I'm going to shift over here, and I'm going to start creating that same setup. So the first things that I'm going to want to grab, I need a breadboard. So I'm going to click on breadboard small right there, and I'm going to drag her in. Come on over, buddy. There you are. There it is. Okay, so there's my breadboard. Oh, it gave me a bunch of them because I clicked it a few times. So one of them is all I need. So I'm going to delete one and then get the extra one. There it is. Okay, now on my diagram, I had it oriented the other way. So up here in the upper left-hand corner, there's a rotate button. I'm going to rotate it a couple times until it's vertical. so that it matches the same way that I saw it. Then I'm going to scroll down further and find an Arduino Uno. I'd also like to grab an Arduino Uno, so I'd take one of those, thank you, and then pull him over, and then same deal, do some rotations until that is sitting right next to my breadboard. All right, so the first thing that I want to do is I want to connect my positive and my negative to the positive and the negative from my Arduino. So in order to make a wire, I click on the thing that I want to connect. In this case, I'm going to connect 5 volts, and I'm going to connect it up to the positive line from that breadboard. Then I can click the negative, and the negative is ground, and then I'm going to connect that to the negative. Now, right now, both of these lines are green, and they kind of look the same, and they crisscross. So I'm going to switch this one, this was the negative one, to black, so that black is always negative. And then I'm going to take my positive one and switch it. Oops, I accidentally made a line there. So I'm going to click and then get rid of it. There it is. I'm going to delete that. So there's my positive line, and I'm going to switch that one to red. And that way I know that positive is always red and negative is always black, and that matches these color lines that are on the breadboard. All right. I also know that I had some different components. Whoops, I've scrolled way too far in. Let's scroll back out there. One of the components that I had was an LED, and another one was a 330 ohm resistor. So over on the side, I'm going to go back up and see if I can find an LED. So there's an LED, and I'm going to drag one over, and I'm going to place that LED in here. And I remember that the LED was oriented the other way, so I'm going to rotate it a few times. There it is. So now it's sideways, and I'm going to place her there. Great. Another component that we had was a resistor. So I'm going to click that and then drag my resistor over. And I think, if I remember correctly, the resistor was crossing the ravine. So I'm going to orient it that way and then place it right there. So the resistor now goes from line 1 over here, F, G, H, I, J, over to line A, B, C, D, E, but it's all in line 1. Then my LED connects over there, and I'm going to go back and just double check. Oh, I know that I also had a potentiometer, so I'm going to click my potentiometer there and drag my potentiometer over here to there, and that guy needs to be rotated too. Rotate around. I'm going to rotate him all the way around, even though it's slow and steady, so that he sits in the right place there. Lovely. Now, it doesn't have to be in the right lines. The lines are all just made-up connections. So as long as they're in the right orientation, I'm good to go. I'm going to hopefully slightly zoom in. It's tough to get the zooming perfect, but there it is. Now I'm going to go back and double-check my connections. So I had my negative side of my LED going into line 1, my positive side going into line 2. I might have to drag my resistor down a little bit. And the other thing that I forgot to do was change the resistance of my resistor. So I'm going to go back in, and negative is there. I'm going to drag my resistor down a line so that it goes into positive, like the diagram. And then when I double click on the resistor, hopefully I can change its resistance, but that's not pulling up right now. I'll come back to that then. Nothing. There it is. Nope, that's the breadboard. The resistor. Lovely. So the resistance right now is listed as 1, and I'd like it to be a 330 ohm resistor. So right now it's set as kiloohms. I need to change that to just regular ohms. So I would need it to be 330 regular ohms resistor, and I'll know I have it right because it's orange, orange, brown, and that matches the one that was on the diagram. So far, so good. Now I'm going to connect a black wire from the negative side of the battery to my negative side there, and I'm going to connect my positive side of my resistor, which is connected to the LED, all the way over to pin 13. Now this one has a lot of zigs and zags in it, and that's great for being able to follow it really clearly. But when I connect mine, it doesn't actually matter how precisely I get it. So I'm going to connect my negative side. Whoops, I connected that incorrectly. So I'm going to delete that again. My negative side has to be over here, line E, so that it's in the same line, and it has to go over to the negative side of the battery. So it's connected negative there, and I'll make that black just so I can remember that's a black connection. There we go, a negative connection. And then over here, my resistor right there is connected to pin 13. There it is, D13, and I'll click there, and now I have a connection there. They made that one yellow in the original diagram, but the color of the wire doesn't actually matter, so I can leave it green, and that's just fine. All right, then I also had my potentiometer connected. The top line of my potentiometer was connected to positive, the bottom was connected to negative, and the middle is connected into A0. So let me go do that. I'm going to do the top line right there, connects to positive, thank you. The bottom line right there connects to negative, there. And then the middle line right there is going to connect to A0. All right. And I'll change the colors on these just to keep it clear. The middle one I'll make blue. The top one is going to positive, so I'll make that guy red. Oops, nope, I accidentally created another line. Sorry, it's that line that I want. Highlight it. Good. Nope, not the breadboard. The line, please. There you are. That line I'll make red, and then this line goes to negative, so I'll make that line black. All right, and now I think I have set up my breadboard correctly. I am just going to double check by glancing here, and I do seem to have all of the wires in place, all of the components in place. Whew. All right, so I've got it set up in my simulator. Now I'm going to scroll down. There's some technical details of other ways that I could set up. And then it says open the sketch. So since we're using a simulator, we're not going to open the sketch in the IDE, but I'll show you what that looks like. Instead, we're just going to click this button, copy code. It's always going to give you the code. So I'm going to click copy code. It says copied. Lovely. Then I'm going to go in here, and there's a button up at the top next to start simulation that says code. I'm going to click on that code button. And it's going to start me with all of these blocks of code. And those are nice, easy drag and drop ways of doing it. But since we have text code, I'm going to click the drop down, and I'm going to go to text. Yep, it's not going to like that, but I'm going to say yes. Then I'm going to delete all of the code that's there, because it's going to give me a starter code. I'm going to get rid of that. And I'm going to paste in, Control V, the code that I just copied. Now I have all of the code that I pulled from Circuit 1B of the Sparkfun Inventors Kit. Perfect. So I've taken that code, and now I am ready to actually run my circuit. So when I run my circuit, I should see my LED blinking depending on how I turn my potentiometer. And then it's going to ask me to open the serial monitor. So I'm going to run through all of that with you now. So here I am. I have my code right here. I'm going to start the simulation. So it's going to start running the code. It's going to send the code into my potentiometer, or sorry, into my Arduino. And then what it's showing right now is not a whole lot. It's really difficult to see that. So I'm going to shift that and make it one that I think is easier to see. I'm going to make it a yellow one. And then yellow will hopefully turn on and off. And I'm getting a whole bunch of nothing. So let me, oh, you know what it is? So what happened is I have my potentiometer, and my potentiometer is set all the way to one end. So instead I'm going to shift my potentiometer by clicking and shift it to the middle. And now all of a sudden my LED is lighting up and not lighting up. Nice. So it's flashing. And I would bet I originally had it set all the way over here on this edge. So I wonder if I set it over here, will it flash faster or slower? It seems to be flashing a little bit faster. I'll go further. Yep, that is definitely faster. And to get rid of the code so it's not blocking my view, I can click on the word code again, and it gets rid of it. I can go even faster, and now it's like it's on all the time. You can see it's barely flashing there, or I could slow it way down by moving it over to here. On, off, on, off, on, off. So now it's going much, much slower. So I can move my potentiometer. I'm basically twisting my potentiometer here. I'm twisting it digitally. But if it's over on this side, then it seems to flash much slower. And if it's over on this side, then it seems to flash much faster. So what I'm doing there is I'm changing how frequently I should flash my light. And I can see that by going into code and then opening up my serial monitor. So down at the bottom, there's a thing that says serial monitor, and it tells me what value it's giving me. So right now I'm at 264, and this is the number of milliseconds in between each flash. So it's going to go on for a quarter second and then off for a quarter second. If I want to make it even faster, now it's reading 123, so that's about 1/8 of a second on and off. I can probably go even faster. Oh, 0. So 0 seconds on, 0 seconds, or 0 milliseconds on, 0 milliseconds off isn't going to do it. Here's 41 milliseconds on and off. It's going super fast. And then I can go all the way up to here, and I'm at like 1,982. The max it seems to get to is 1,023. And that would be about a whole second on, a whole second off, whole second off, whole second on, whole second off, whole second on. Cool. So you can see that as I move it around, I can change what my serial monitor is reading. About halfway is 491. That's about a 500 out of 1,000. That seems to make sense. Half a second on, half a second off. All right. So next, I'm going to go through and I'm going to try to figure out exactly what the code is telling my computer, which is my little Arduino, to do. So to do that, I'm going to start by going back and just double checking that yes, it is doing what I'm doing. Read the program, read the position of the potentiometer. Good. Wait. Turn the LED off. Wait. Repeat. All right. And then the serial monitor tells me what the potentiometer is reading. So under code to note here, it has some suggestions of really important code that is listed that we might want to take note of. And then it has coding challenges. If you're feeling fired up on this and you want to do some additional bonus stuff, those are some fun stuff to do. For our purpose, though, we're going to go in and we're going to try to figure out in our programming notes what these codes mean. So circuit 1B, the first code that we're going to try to figure out is what int pot position means. These two lines / mean after this is going to be a comment. So I'm going to type in my comment after that. So in here, the first line says int pot position, and then it has a semicolon. The semicolon means it's the end of the line. I can see that int is a different color. It's like a brown or an orange, and then pot position is in black. So what it says is this variable will hold a value based on the position of the potentiometer. So as I'm reading that, I know that int from circuit 1A, int stands for integer. So I'm setting an integer or a number, and I'm calling that number pot position. And pot stands for potentiometer, and position is the position of the potentiometer. So what I'm going to say is this sets an integer, which is a number, that is going to be the position of the potentiometer. Okay, so I'm just calling this integer pot position, potentiometer position, and that's going to be the position of the potentiometer. All right. The next one is serial begin 9600 semicolon. So when I go into my code in void setup is the part of the code that I only want to run once. It sets up the rest of my information. It says serial.begin 9600 semicolon, and 9600 is in parentheses. So that is code to the Arduino board to start a serial connection with the computer. So that basically means send whatever you're taking in and send it to the Arduino so that we can read it in the serial monitor. So I'm going to open up my notes again. Oops, sorry, I accidentally stopped sharing. Let's go back. Great. I'm going to open up my notes again. Where are they? Right there. Nope, right there. No, go away. There. Okay. So this opens up the serial monitor and connects it to the Arduino so we can read what is being inputted to the Arduino. So basically, what's the Arduino reading? What's the Arduino taking in? In this case, what it's taking in is the potentiometer. So the next one is pot position equals analog read A0. Okay, so if I look at the next one, so in setup, I've got pin mode 13 output. That just indicates pin 13 is going to be set to sending information out. That's the one that's here, sending the information out to the LED. And then in the loop, the first thing I'm going to try to do is read the position of the potentiometer. So pot position equals analog read A0. If I remember correctly, that's the one that I want. Pot position equals analog read A0. Perfect. So this one sets potentiometer position to a number between 0 and 120 or 1023 based on how far the knob is turned. So I'm taking pot position, which was a variable, and I'm saying read A0, and A0 is connected to my potentiometer. Take that reading and put that number in for the variable potentiometer position. So I'm going to say read the potentiometer, which is plugged in to A0, and put that value, which is between 0 and 1023, put that value in for the variable pot position. Pot position itself has no meaning to a computer. It's just a random string of letters. So now we're saying pot position is going to be whatever this number is. It could be 0, it could be 5, it could be 123, it could be 248, or it could be anywhere up to 1023. Then the next part of this circuit is it's going to serial print ln pot position. Then digital write 13 high, delay for pot position, digital write 13 low, delay for pot position. So digital write 13 high means turn on pin 13, turn on the LED. Delay for pot position means wait for however long the serial monitor is showing. Digital write 13 low means turn off the LED and then wait for however long the potentiometer is showing. And then the one that we wanted was serial print ln pot position. So that one is print the value of the potentiometer position in the serial monitor on the computer. So serial print ln means print this in the serial monitor, and we're going to print the value of potentiometer position. And I got to be honest, I think they've done a dang good job of explaining that one, so I'm just going to copy and paste that one, print the value of pot position in the serial monitor on the computer. Cool, that makes sense. Print the value of pot position on the serial monitor of the computer. That seems pretty good. So that's serial monitor, print, and the value that I'm printing is pot position. And the pot position it's going to print is somewhere between 0 and 1023. All right, so I think I understand. Oh, the last question is, what does it say on your serial monitor? Let's see, looking right now, it says 491, but it has varied anywhere from 0 to 982, but I think I can get it higher, 1023. But right when they asked, it was at 491, 471, 593. I'm going to say 471. Oops. Share that screen again. All right, so going back to my notes there. There they are. Boom. What does it say on my serial monitor? It says currently it was 471, but it ranges from 0 to 1023. So it can give me any value between those values. All right, and now I think I understand how the potentiometer is working. Remember, when I want to get rid of the code, I can just click the code button. It keeps doing its thing. The light is still flashing. Maybe I want to stop the simulation. I would click the word stop simulation. And then if I want to get rid of this thing and then start a new one, I could open up a new component. So if I wanted to share this with somebody, like here's how you set it up. For example, once I've made my robot art show and I want to share it with my teacher, I could go to share, and I'm going to invite people, and it gives me a code, and I could copy that code and then send that code to my teacher so that they can see the cool thing that I have been able to make. You don't have to do that for all of these designs. Just do that when you start making your own stuff. And then, oh, look at that. There's a zoom to fit. Huh, that's helpful. Or I can zoom in extra more to make it fit even closer. There we go. So again, to get the code out, click the code, then you can read it. You can scroll through here. To get the serial monitor, you click the word serial monitor. To get rid of the serial monitor, you click the word serial monitor. To make it go, you click start simulation, and it's pretty much user-friendly from there. So good luck. Run through all of those various things. If you close it out like that, you can always reopen it by going to TinkerCAD Circuits. There it is. Launch TinkerCAD Circuits. And it'll give you a brand new one to run from. And if you want to see your previous stuff, I think you can click on your profile and open up previous codes. So now I'm back. I can do another new one and run from there. All right. So last thing to mention is I think this is a tremendously fun project. You get to run through like 15 different electronics experiments. They get more and more complex and more interesting. Full disclosure, they're also really, really hard. And you're going to try to teach yourself how to code and how to create electronics. And that's really, really difficult. So if you're finding yourself getting a little bit frustrated, that's okay. Take your time with this. Slowly work your way through each one. I'd say if you get through like 3 or maybe 4 circuits per day, you're doing really, really well. For about half of you, this will probably end up being like your favorite project because programming is really interesting and it's like solving puzzles and you get to make it do cool things. For the other half of you, you will discover that this is 100% not your thing. And that's okay. We've done a bunch of other stuff this year that has been your thing, and you know that you love science and there's a part of physics that you really like. And that's great. And if you happen to find out that electronics and programming is also super cool and you love that, even better. But if you don't, that's okay. You don't have to love every single thing. It'll be especially tricky because you're going to try to do it on your own from home using the simulator, but I think you can do it. If you have questions, make sure you reach out and ask those questions. And you can always go back and rewatch this and see how you put this stuff together. Remember, you can copy the code straight off of the instructions. So these instructions are going to be really, really helpful in the Sparkfun Inventor's Guide. Where are they? There you go. After you've read through everything, when you're ready for the next experiment, you just click next page. Boom, you're on to the next one. Scroll through. It introduces a new component. Now it's a photoresistor. You keep going. You set it up like that using the circuit diagram. You might even want to minimize both windows and have them alternating. So you've got like one window here, so that you can see like whoop, 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 whoop. Here's my circuit diagram, and I'm going to create it just like that. So, you take that one, make it half size like that. Ka-choo! So that it's sitting there, and then open up your other window here for your circuit diagram. Can I do that? Yes, I can. Look at me. And now I can design my circuit here while having the visual right there. I probably should have done that the first time. That makes a lot of sense. Okay, so I'm back on here. There's my circuit diagram. And then when I'm ready to copy my new code, I go down here, I click copy code, steal it, pop it in under code. No program. Oh, okay. So first you have to put in your Arduino in order to be able to code anything. Sorry about that. So step one is you got to steal an Arduino right there, please. There it is. Now I've got an Arduino. Now I can go code. Every time you're gonna have to go from blocks to text, continue, get rid of the old text, and you have to make sure you get every single thing. So even if there's just a tiny little bracket there, that will screw everything up. New text, boom, set up your new circuit, and then let it rock. And then you figure out what the new components are. There's a whole bunch of, ooh, this is cool. Now you're going to learn if-else statements. Fun. And then you write down those pieces in your programming notes. So, oh, yep, it's going to introduce int threshold, int photoresistor, and then do an if-else statement. So every time you open a bracket, that's the other piece, you have to make sure you close that same bracket. If you don't close the bracket, then you're going to have trouble down the line. It'll not run the code for you. All right. So with that, persevere with this, do your absolute best, and see if you can make something cool. All right. Good luck with it, guys.